Okay, so today we're going to talk about binomial events. And what binomial events are is it's a type of probability that deals with independent events. And these are the different things that you need for a binomial events. You first need it to be binary, meaning it only has two kinds of outcomes, a success or a failure. That's it. The second thing you need is it to be independent. So no other trial affects another trial. The next thing that you need is you need to have a certain fixed number of trials that you're going to do. You can't run infinite number of trials. You can only have a certain number of these things. And then you need to make sure that you know how many successful trials that you want to run. So again, the different things you need for it to be binomial is you need it to be binary, meaning two outcomes, independent, a certain number of trials, and you know how many successful trials that you would like. Let's see a binary event and see if we can find some of its probability. Okay, so here's our event. Let's suppose that we are looking at kids' genetics and their probability that they have O positive or O negative blood. And so let's assume that the odds of you getting O positive or O negative blood is 25%. And let's say that these parents over here are going to have 5 kids, and they want to know what's the percent chance that 2 of them have O negative blood. Well, the chance that they would have O blood would be 25%. So the chance that they wouldn't have, so that's our success, would be the opposite of that, which should be 75%. So this would be a fail, that they don't have it. So again, we know this is binary because we have two outcomes, a success and a fail. And we'd like 2 of them to be successes. So we would do, if we want to figure this out, we should have 2 successes and 3 failures. So that probability would be 25% times 25. And then times them by the 3 failures, which would be 75% times 75% times 75%. And then when we calculate that all, that should be about 3%. Which seems kind of low. And it is, because this isn't the only way that we could get this. This would say that the only way is success, like the first 2 children would have O blood, and the 3 others would not have it. But we could have a person that had O negative blood, then the second child could not have it, and then then fail. So there's different ways to write this. And if we calculate all the different arrangements, which I did ahead of time, there should be 10 of them. So there should be 10 different ways that you could write all those things. And so we would have to take this number and times it by the number of arrangements, giving us around 26%. Okay, so that's how we deal with a binomial event. We can actually look at this equation in a different way, which this is kind of the normal way to look at it, where you say this is the number of arrangements you have. And this would be the successes you have. And this, right here, would be your failures. And it would make sense that, okay, if that's the probability of your success, the opposite would be the probability of your failure. And if you had K successes and you had a certain number of trials, saying N number of trials, that if you took away the successes from the number of trials, that'd be the number of failures. And this arrangement, if you want to know how to find these arrangements, you probably have seen this before. It comes off of Pascal's triangle, but we don't need to get into all of those different things. You just need to know that these are combinations. And how we would calculate this is we would take the combination of the N trials with K successes. And that's kind of how you write that, and that's how you'll write it in your calculator. And we'll see after we kind of solve through a problem. So I'm going to solve through a couple of these problems to show you how you would do all these calculations by hand. Okay, so here's a normal problem that we might get. A die is weighted so that the probability of rolling a 6 is 42% of the time, and we roll the die 12 times. And I want to know, what's the probability that I get a 6 twice? So what's the probability that I get a 6 twice? And so if we do this, I want to figure out my successes, which would be 0.42. And then my failures would be the opposite of that. So that would be 58%. So 42% of the time is my success, 58% of my time is failures, and I would like there to be 2 successes and 10 failures. And then the last thing I have to figure out is how many arrangements I would have, which would be this combination. So there's 12 trials, and I want 2 successes. So this is, again, this would be my arrangement. Which that's going to be a very big number. This is going to be my success. And this is going to be my failure. Let's see how we would get this all in. So I'm going to take out my graphing calculator. And I'm going to type in 12, because that's the first thing on my arrangement. And if you want to find this combination tool on your calculator, it's in here under Math under Probability, and it's combinations, not permutations. We would have 2. And then we want to times that by 0.42 to the second power, and then times that by 0.58 to the 10th. And we can see that the odds that are out of 12 attempts, if I roll exactly 2 6s, it'd be about 5% of the time. Okay. Let's try 2 more of these problems. Okay, so now, let's say I have this, which would be the probability that I roll a 6 10 or more times. So this one's a little bit trickier, because these are the probabilities I need to figure out. I need to find the probability that I roll 10, plus the probability that I roll 11, plus the probability that I roll a 12. So we're going to have to find all of those. So the probability that I roll again, or roll a 10, would be 12 C10, because that's my number of things, and that's my number of successes, so this would get my arrangement. And then, again, it's still 42% of the time, and I would have 10 successes this time, which means I would only have 2 failures. So that would make this probability. Now for the second one, it'd be 12 combination 11. The same kind of thing. Whoops. But this time, instead of 10 successes, I wanted 11 successes. Plus the last one. So that was the one in the middle. Which would be the same thing, but this is 12, combination 12 successes. And I would want 0.42 to the 12th. And I really don't need to write any failures since I have 0, and anything to the 0 power would be 1. So it really doesn't do anything for me writing a 0 over here. So this would be it right here if I can fit it all in. And then I would have to type that in on my calculator, which would take just a little bit. So I'll get you started, and then I'll have you check. But you'd have to start with your 12, and then go to your math probability. And we're going to find a quicker way of doing this tomorrow, because this takes a significant portion of time to do. But I'll type in the rest of this in a second, and then we'll see what probability gets us. And as you can see, after I type all that in, which is a lot, the probability would be less than 1%. And that kind of should make sense because it would be really odd for us to roll it a 6 that many times, or like a 6 10 times, or 11 times, or even 12 times. So it's a very, very low percentage that you should have gotten. So the very, very last thing you could do is you could do an event that was less than. We're not going to type all that in because you would have to go all the way. Or if I wanted to go less than 10, the easier way is if you did the probability that x is less than or equal to 10. I could find the probability of 0 plus the probability of 1 plus the probability, but that would take a while. If you already know what it is for 10, to find that, we could just do the 1 minus the probability that x is bigger than 10, and that would give us this opposite. So if you ever want to find the less than of something, if you subtracted 1 from the greater than, that should work. It's not too bad to set up, but that's the general gist of these things. You first, for any of these events, you want to find the arrangement, then the successes, then the failures. And then multiply everything together and see what you get.